Hello everyone. In this video I'll be talking with you about a couple of math problems that I have, and I'll be presenting that on some PowerPoint slides. So let's go ahead and take a look at those math problems that we have. Okay, so we are on to our basic math problem set number 4 with a total of 2 problems in this math set. Problem number 1. The numerator of a fraction is a positive integer that is 2 less than the denominator. The sum of the fraction and its reciprocal is equal to 25 over 12. What is the fraction? We have some answer choices here. Our first answer choice is 6 over 8. Then we have negative 6 over 8. Then 8 over 10, or 10 over 12, or negative 16 over 18. Okay, so how would I solve this problem? Well, first I'd come up with a basic form based off of the description that we have in our problem, which is 25 over 12 equals n over d plus d over n. N is going to be the numerator, d is going to be the denominator. Now recall that it did say you're going to add the reciprocal of that fraction to itself, and you're going to have a result of 25 over 12. And then next I would make sure that I took note of the specification that n, which is the numerator, is going to be equal to d minus 2, okay, which is the denominator minus 2. Next I'm going to add up the fraction on the right hand side. So n over d plus d over n is going to equal n squared plus d squared over dn. Next, equate the added fraction to the final evaluation. So n squared plus d squared over dn equals 25 over 12. So we automatically can see that dn must equal 12, and n squared plus d squared must equal 25. These are our constraints. So next I'm going to decompose 12 into its factors. Now I'm going to be using its prime factors. So the prime factors of 12 are 2, 2, and 3. So next, using the prime factors, n squared plus d squared, I'm going to put in place of that, using the prime factors, I'm going to put in a 2 here for n, and I'm going to put in 2 times 3 for the d. And so 2 squared plus parentheses 2 times 3 squared is going to give us 4 plus 36, which is not equal to 25. So I'm going to use trial and error again, and I'm going to rearrange and have n squared plus d squared equal 3 squared plus 2 times 2 in parentheses squared, and then that's going to give us 9 plus 16, which is equal to 25. So we've met that constraint. So that reveals to us that n is equal to 3 and d is equal to 4. Since these are factors of 12, they will meet the denominator constraint. So n times d equal 12 is just simply 3 times 4. Recall from our starting point that 25 over 12 equals n over d plus d over n, which equals n squared plus d squared over dn. So putting in 3 for our n and 4 for our d, we have this form: 3 over 4 plus 4 over 3 equals 3 squared plus 4 squared over 4 times 3. Next, for the specification that n equals d minus 2, just change the form of the fraction, because as of right now, n is only 1 less than d. So we're just going to change the form of the fraction. So 3 over 4 times 2 over 2 equals 6 over 8. Now that meets that specification because 6 is 2 less than 8. And so we'll do the same thing for the reciprocal, which is 4 over 3. So 4 over 3 times 2 over 2 is going to give us 8 over 6. So to check the final form, we're going to have 25 over 12 equals 6 over 8 plus 8 over 6. And so to get a common denominator, we're going to have 6 over 8 times 3 over 3, and we're going to have 8 over 6 times 4 over 4. That'll give us a common denominator of 24, and then our numerator we will add as 18 plus 32, and then that is going to give us 50 over 24. We can then divide out 50 by 2, divide 24 by 2, and then we can get the form 25 over 12. So in our answer choices, we had 6 over 8, negative 6 over 8, 8 over 10, 10 over 12, negative 16 over 18. And so the answer is A, 6 over 8. That is the fraction that we are talking about because we can clearly see it here. We just made sure that we confirmed that that is actually the case here. And just as an extra note, the reciprocal is 8 over 6. Now, on to problem number 2. A pencil shop has received boxes of red pencils and green pencils. The box of red pencils contain 10% broken, and the box of green pencils contain 4% broken. If the total number of broken pencils is 66, and the total number of green pencils is 3 times the total number of red pencils, then what is the total amount of pencils the shop received? So how would I go about solving this problem? Well, first, the number of red pencils broken, I'd begin to symbolize it and make an equation for it. So R sub B equals 0.10 R sub T, where R sub B equals the broken red, R sub T equals the total red. Next, the number of green pencils broken is G sub B equals 0.04 G sub T, which equals 0.04 times 3 R sub T, which equals 0.12 R sub T, where G sub B is the broken green pencils, G sub T is the total green pencils. And so again, recall the relationship that 3 times R sub T is equal to G sub T, which is the total number of green. So 3 times the total number of red equals the total of green. And we just put that in here. And now we have a figure of 0.12 times R sub T equals G sub B, which is the total number of broken green pencils. So next, since all of the red broken pencils and all of the broken green pencils equals the total amount broken, which is given in the problem description as 66, then what we can do is we can have 0.10 R sub T, make these substitutions, plus 0.12 R sub T equals 66. Again, T sub B is the total amount of broken pencils, which is 66. So making the substitutions, now we have only one variable that needs to be solved for, which is R sub T, which is the total amount of red. So now we add those two together and we have 0.22 R sub T equals 66. And then just rearranging with some algebra to isolate R sub T, we have R sub T equals 66 over 0.22, which gives us a ending evaluation of 300. So next, recall that the given relationship for total green to total red. So we have R sub T is 300 there. G sub T equals 3 times R sub T. And we just figured out that R sub T is 300, so we just simply multiply that number by 3, and that will give us G sub T, which is the total number of green. And so G sub T equals 900. Next, recall that R sub T, which is the total amount of red pencils, plus G sub T, that's the total amount of green pencils, equals T, the total amount of all pencils, which is just simplified to be 300 plus 900 based upon what we figured out. 300 plus 900, which is going to give us 1200. So again, T is the total number of pencils, which is 1200. So the final answer is 1200 total pencils. So this brings us to an end of our fundamental math problems in this set. And as always, practice to scale up your fluency in the subject matter. Thank you for watching this video. Hopefully it was helpful for you, and have a nice day.